So what we were doing in the last lecture we were doing problem on electrostatics, and precisely the problem contained एक minute ago. So that problem contained this particular thing. Okay. So if you have any doubt, please ask me till now. Just finding a question. Let me see if it's there, then we could. Otherwise, fine. So what I would suggest is, whenever you have this r cap upon r square kind of format, just keep care that it may be possible. It is quite possible that your Dirac delta function is may come, and probably you are in the lack of awareness you do that entire question without taking in account that Dirac delta functions. That is why I'm reiterating. Kindly keep care of this particular fact. Okay. Now you see, if so, the entire question I'm reiterating. So what was the question? The question suggested that if I have this thing, if I have my electric field written in this format, that is a e to the power minus br upon r square. So generally you have this kq upon r square. Instead of kq upon r square, your electric field contains some e to the power minus br term. And kq upon r square kab hota hai? Only when there's a point charge. So now, obviously, this charge density, this kind of electric field in the space cannot be manifested by your charge q. That is not a point charge q. So obviously there would be some different sort of charge distribution in the space, which gives rise to such an electric field. So the question asks, what kind of charge density can give rise to such a field? Answer to this problem would be that we'll have to see what is my del dot E vector. So if I just try to find what is my del dot E vector, I find that my charge density contains a point charge at the center, and forget about this e to the power minus br, because see, this particular charge, this particular e to the power minus br is accompanied by Dirac cube of r, and which is only non-zero at r equal to 0. For r not equal to 0, it is overall 0 only. So overall, only at r equal to 0, it is going to give something. And r equal to 0, in case if integrated, this will become 1 only. So overall, at times in books, you'll find this particular thing written as 4 pi epsilon naught a Dirac cube of r. So what does it imply? It implies that Dirac cube of r is accompanied by a constant value, and this constant value will give you the magnitude of the point charge, which is located at r equal to 0. And surrounding to this particular point charge, you have this kind of density, which is negative. So this is a negative point charge density. Also, it is exponentially decaying. You can see this is exponentially decaying all over, damped by a factor of r square. So overall, it is again damped by a factor of r square. So not only that, it is decreasing exponentially, decaying exponentially. Also, it is all the more worsened or all the more decaying because of this division by r square. Is that clear to you?
Yes, sir.
Okay. So overall, understand this particular fact, and this particular thing I yesterday draw also. I drew also. So basically, draw also. Here it is. So you have a infinite point. You have a point charge at r equal to 0, and when r is not equal to 0, you have e की power minus br. E की power minus br officially कैसा लगता है? ऐसा कुछ लगता है. इसका negative लेना है, and that also for this is r. So this is my epsilon naught e की power minus br upon r square. This is my negatively charged cloud, or you can say sort of density around r equal to 0. And at exactly r equal to 0, I have this kind of point charge. So you have a point charge exactly at r equal to 0, and surrounding r equal to 0, you have this negatively exponentially decaying sort of cloud. Is that clear to you? Now, if you are asked about what would be your total charge, so what would be your total charge of the system? So total charge of the system, you can write integral of what was there, 4 pi a epsilon naught e to the power minus br Dirac cube r d tau. This will be from all space, plus minus epsilon naught a e to the power minus br divided by r square. And this is not defined at r equal to 0, so it will be from 0 plus something to infinity, and this will be r square sine theta d theta d phi dr. So if you enclose this particular sort of density, so for example, if I want to find the total charge, what I'll do, I'll enclose it in some Gaussian surface. So here is your point charge, which is given by 4 pi epsilon naught A, and it is enclosed by an exponentially decaying. So your charge density, if I make broader lines here, I'll make smaller, smaller, and feeble lines. Okay, so this is how my charge, negatively charged, will be distributed around your point charge. And if I make a, what you can say, if I make a Gaussian surface of infinite Gaussian of infinite radius, basically it will enclose my entire charge of the system governed by this particular density. Okay, so if I make this kind of radius, and if I take r tends to infinity, or even if I take simply till infinity, what I would get is I would get what is the total charge. The total charge is given by rho d tau. Total charge is given by rho d tau, and rho is given by this plus this, and d tau is this. So this will give me what? The first term will give me 4 pi epsilon naught a, and the second term will give me epsilon naught a, and this will be like r square gets cancelled with r square, and you have this sine theta, and this sine theta will give you 2, and this will give you 2, this will give you 4 pi, this will be 4 pi, integration 0 to infinity e की power minus br dr. And even if you want to take h and h tends to 0, that also is fine. Okay, and this e की power minus br would overall give me what? Where is that term? So where is that term? I don't know. There is a is there, 4 pi epsilon naught is there, e की power minus br is there. Okay, and there should be some b somewhere. I don't know. There should be b somewhere, because otherwise this b will come. Just let me see. And there's a b also. So there's a b also. So it will give me some b also here. Okay. So if I integrate it all over, what I would get is, this is adding up. What is happening? Just find if there's a mistake here somewhere. I think this is fine. Minus epsilon naught a e की power minus b upon r square, r sin theta d theta d phi, and from 0 to infinity. Okay. So if I integrate it, one negative will come out. So if I integrate it, it will be 4 pi epsilon naught a, and there will be some e की power minus b divided by minus b. So this will become 4 pi a epsilon naught e की power minus b from 0 to infinity. At infinity bit will go 0, and 0 bit will become 1. So it will be 4 pi epsilon naught a minus 4 pi epsilon naught. So overall charge enclosed inside this entire Gaussian surface is rho d tau, and this particular thing will become 0. Overall charge, total charge is 0. Or you can take, if you want to really use the concept of Gauss law, what you can do is, because I have made this particular thing, I can take my E dot ds over close sphere of radius capital R, and I can say this is total charge enclosed divided by epsilon naught, divided by epsilon naught. So if I want to find this, if I want to find in this manner, also I can find, given that limit r tends to infinity. So if I take E dot ds, what it will become? E vector I already know. That is, I think E vector is given by epsilon naught a e की power minus br upon r square dot. Achha, if I take this radius capital R, it will be all r square sine theta d phi integral r tends to infinity, and this is equal to total charge enclosed, and this will give me, I think, total charge enclosed would be equals to r square gets cancelled from here. This will be like 4 pi epsilon naught a e की power minus b capital R with the condition r tends to infinity. This will again give me that total charge enclosed by the system is equals to 0. And that it certainly reminds you of the old sort of model of atom, that there your entire charge is located at the center and surrounded by an electronic cloud. So this represents your electronic cloud with an exponentially decaying sort of variation. And in fact, it's not only exponentially decaying, it is also further damped by a factor of r square. Is that clear to you? So whether you take Gauss law or you take root eta, the entire total charge would come out as 0 in any case. I also told you yesterday that if you want to integrate it from 0 to capital R, then there is a problem because you're at 0, there is a singularity. At 0, there is a sort of singularity. There is an infinite contribution. So it will eventually start from 0 plus h. So in that way, you will have to circumvent it with some circle and do that problem. It will take time. So that is why I'll take you to, I'll do that problem for your convenience tomorrow, but you will see that this will be a long affair. Meanwhile, let us see that if instead of my electric field, instead of potential is supplied, till now everything is clear. I don't think everybody's following everything, right? Or is there something that you don't follow? कोई चीज नहीं समझ में आई तो प्लीज पूछ लो. आगे चलो बढ़िया. So if at all, so tomorrow again we are going to do Coulomb's law. ठीक है, थोड़ा सा हम Coulomb's law पढ़ेंगे so that देखते हैं क्या कैसे होती चीजें. ठीक है, so if now try to find this. So I'm giving you थोड़ा सा time and let us do this. The electric potential. So now instead of field, now you have electric potential of some configuration. Is given by this. So potential is given by a e की power minus lambda r upon r. So now you don't have r square, instead I have only r. So you remember this. So दो चीजें याद रखो. Whenever your potential is given as some function of 1 upon r, and electric field is in some way r contains this term r cap over r square, you can be quite certain that you're going to meet a Dirac delta function. Why? See, if you want to find, and if you're asked about rho, you're certainly going to meet Dirac delta function. Because see, if electric field is given in the format of r cap upon r square, then del dot E vector would somewhere contain this del dot r cap upon r square term. And if your VR is having some 1 over r term, then obviously del square 1 upon r. This will be minus 4 pi Dirac cube of r. Why? Because you see, what is del square? So del square is del. This is what is del square, isn't it? This is Laplacian operator. It can be written this way. So del dot. This is grad of 1 over r. Or grad of 1 over r क्या होता है बताओ? This is minus 1 upon r square r cap. So this is del dot minus r cap upon r square only. So del square 1 over r is minus 4 pi Dirac cube of r. So this is a kind of insight I'm sharing to you, that whenever your electric field, and this is quite often you'll find that your electric field is some r cap upon r square only, because your Coulombic force is in inverse square law force. So mostly you'll find in this fashion only. So ये थोड़ा ध्यान रखना. Otherwise there will be mistakes that you're not going to, तुमको पता ही नहीं चलेगा. Okay.
Yes.
देखो, if potential contains some, if potential is defined by a e की power minus lambda r upon r, where a and lambda are some constants, and as long as not mentioned, take them as positive constants. Okay, we have to find what electric field as a function of r. We have to find electric field as a function of r. We have to also find what sort of charge density can give rise to such a potential, and if at all this charge density gives rise to such a potential, what will be the total charge of the system? What is the total charge of the system? So now instead of electric field, you are having this kind of potential given to you. And if things like field and all those things are being asked, then how to go about such a problem? So you already know that since this particular thing you know from the conservative vector field, since electrostatic field is a conservative vector field, electrostatic field is a conservative vector field, or electric field is a conservative vector field. This thing that you already know from your standard 12th or whatever. So you know that if there is an if the field is conservative, then it can be represented as minus of grad of some scalar function, and that scalar function is called as the potential function. Is that clear? Minus is to resolve the discrepancy of direction and all. overall you can represent it in the form of grad of V. Is that clear to you?
Yes.
So electric field, it would be quite easy to extract from given this potential. So given potential, your electric field can be written as minus of del upon del R, because only there is a radial component, so I'm writing del upon del R. And you have this A e की power minus lambda R upon. And I think you'll get some, we'll have to see, and this R cap also, because you're finding grad of this. So this will be like, let us find it. थोड़ा ढंग से कर ही लेते हैं, because otherwise there will be mistake. So this will be lambda A e की power minus lambda R upon R, and then there will be minus A e की power minus lambda R upon R square, and then you have, I think you will have R cap. Is that clear? I don't think I have made a mistake anywhere. So if I take A की power, अच्छा एक negative
It
बाहर,
will be positive, no?
हाँ, this will be positive because there is a negative outside. Okay, so overall it will come out as A e की power minus lambda R, and then I should have, if I take R square also common, so I will have 1 plus lambda R. Is that clear? So your electric field comes out as A e की power minus lambda R upon R square into 1 plus lambda R cap. Is that clear? So your electric field, if I have a potential of this form, that is A e की power minus lambda R upon R, then my electric field would be equals to A e की power minus lambda R upon R square 1 plus lambda R cap. Is that clear?
Yes.
Okay. And I'm quite aware that my del dot R cap upon R square, I'm quite aware that my del dot R cap upon R square is given by 4 pi Dirac cube. This is something that I know. I'm not very expert in handling Laplacians, but I'm expert in handling this. Otherwise, there are people who are quite aware of this del square thing also. I'll do a question according to this also, but I feel a certain amount of fear while handling this kind of object. So therefore, I'm not touching upon that. I'll see if I can do for certain problems, but overall, understand my point that del dot R cap on R square is 4 pi Dirac cube of R. Is that clear? And if I want to find the charge density, then I should find del dot E vector. And I know my electric field is given by this particular expression. So I would say my rho as a function of R would be, what should I do? I told you I would do one thing. I would take this R cap over R square separate, and there would be some function of R here as a separate entity. Is that clear? So what I would do, rho upon epsilon naught is equals to del dot. Now I'll write थोड़ा सा देख के ऊपर होगा कहाँ गए. This will be, इसको थोड़ा ध्यान से करना है, इसमें गलतियां होती. E की पावर minus lambda R into 1 plus lambda R. This is your sort of scalar thing, and then this is a vector thing, R cap upon R square. Now, if you write first thing, that is E की power minus lambda R 1 plus lambda R, this will be 4 pi Dirac cube of R. So del dot this thing plus gradient of this dot R cap upon R square. So gradient of this would be what? So this will be, I think, del by del R of A e की power minus lambda R. Then you have 1 plus lambda R, and then you'll have, I think, R cap, and then you will have R cap dot of R cap upon R square. Is that clear to you? So overall, if I just find this rho as a function of R upon epsilon naught, you'll find A e की power minus lambda R, and you have 1 plus lambda R, and this will be 4 pi either take Closco, and this will be Dirac cube of R. Is that clear?
Yes.
Okay. And for simplicity, I know that this is valid only for R equal to 0, so you can also place R equal to 0 here and forget about it. So you'll have this 4 pi A, and e की power minus lambda 0 also will become 1. If you want to do that, you can do that. But you cannot argue in the examination that why they have forgotten this particular term. Why they have forgotten? Because they know that if you have to see how your Dirac delta, if you see how your Dirac delta function behaves, you know that your Dirac delta function is non-zero only for r equal to 0. If r is not equal to 0, then all these terms are 0. So forget about it. So at r equal to 0, what will happen? This will become 1, this will become 1 plus 0, and this will become e ki power 0. So you can simply say that at r equal to 0, I have this 4 pi a as an accompanying term. Is that clear?
Yes.
And then if you differentiate it, so so it will be minus lambda e ki power minus lambda r, and then there will be 1 plus lambda r here. And then there will be a e ki power minus lambda r into lambda. And then you will have r cap, and then you will have r cap. Is that clear to you? And you see, this is a lambda e ki power minus lambda. So this is minus a lambda e ki power minus lambda. Forget about it. So what we'll get simply, I think this will be rho r upon epsilon naught. And this will be 4 pi a Dirac cube of r. And then you will have, I think, minus lambda is lambda square. So you'll have a, you will have lambda square. I think you'll also have some r, and then you have this r square. So this will be r, and this r cap dot r cap will become 1. So and this e ki power minus lambda r will also be. So overall, I think this will be the term. So this is how your, sorry, if I multiply it with epsilon naught also, this is how your electric field was, electric field gave this kind of charge density, just a problem before. So basically हो क्या रहा है, अगर तुम इसका इलेक्ट्रिक फील्ड वर्जन बनाओगे ना, तो अगर if you want to find the electric field is, except for this 1 plus lambda, everything was same in the previous question. This extra term came, this 1 plus lambda extra term came, but overall the electric field, this charge density is again some charge located at the center, and which is accompanied by a exponentially decaying charge density, which is accompanied or which is surrounded by an exponentially decaying charge density. Is that clear to you?
Yes, sir.
Okay. What do you expect your total charge to be? So your total charge would be integral rho d tau. So that would be equals what? Integral 4 pi a epsilon naught Dirac cube of r d tau on the entire space. And then you will have minus epsilon naught a lambda square, and this I think would be some 4 pi r, because if you integrate r square sin theta d theta d phi, you will get 4 pi r square into dr. So this is why I've written 4 pi r e ki power minus lambda r d from 0 to infinity. Is that clear? Okay.
Yes, sir.
Okay. So this will eventually lead me to integral. This is 4 pi a epsilon naught minus epsilon naught a lambda square, and 4 pi will also come out. Integration r e ki power minus dr. So this will be e ki power minus lambda r upon minus lambda minus integral r ka derivative is 1. R ka derivative is 1. And e ki power minus lambda r's derivative will be plus 1 upon lambda. And again, e ki power minus lambda would be there. So this would be minus 1 upon lambda square e ki power. Let us do it. Otherwise, there will be mistake. Jaldibazi.
Yes, sir, it's right. E ki power minus lambda r within the limit 0 to.
Sahi hai na? This negative would be there, or it will not be there. I think this will not be there. It will be there.
It will be there because sir, 2 times we are doing. No, first time the first negative will become positive, and then again.
See the in the second kind in second. अच्छा this lambda देखो कर ही लेते हैं यार, इसको 2 मिनट लगेंगे. देखो first thing is r e की पावर minus lambda, so e की पावर minus lambda, ये तो हो गया काम खत्म. ठीक है. See at r tends to infinity, sorry, as r tends to infinity, this will become 0, and at r equal to 0, this will become 0. So overall this term will not be there, so forget about it. अब बचा क्या माइनस डेरिवेटिव ऑफ r is 1, e की पावर माइनस लैम्डा r will give you e की पावर माइनस लैम्डा r upon minus lambda. Okay, so this negative and again a negative, overall it will become positive. And
And
again
then
if I
again,
integrate it, so I think again I'll get a negative. Okay, is that clear? So overall it will give me q is equals to 4 pi a epsilon naught minus epsilon naught a lambda square 4 pi, and this will be plus lambda square e की power minus lambda r from 0 to at infinite this is 0, and at 0 it is minus 1. So overall this will become minus 4 pi a epsilon naught. This will get cancelled. The total charge enclosed by the system is 0. Is that clear? Is that clear? Okay. So such questions may be asked in the examination. So this is what I have for you today, and we'll do a few questions on TFR and everything, so that I will have to figure out the similar problems to all these things. But meanwhile, you should understand one thing, that whenever you have this your potential expressed in some 1 over r, be cautious. Be cautious while deriving the expression for charge density, and if your electric field is given in some form r cube over r square, then again be cautious, because there may be a contribution, a point like contribution that you may be skipping, that you may be skipping. Is that clear to you? And if you
yes,
give me
sir.
a minute, I'll share that TFR question also with you. Just give me a minute. If I find that up, I'll share you. I'll share you within a minute. Otherwise, we'll wind up the class.
Sir, sir, I have shared few TFI problems in which first problem is like similar to this.
Okay. So give me a minute. I'll share you that particular problem.
Sir, I have shared the problem on WhatsApp group.
Yeah. I saw the problem. Just give me a minute.
Okay, sir.